All right, guys, we're going to talk about
Welcome to my
squares.
channel.
Yes, welcome to my channel. We're going to talk about some math. All right. Now, on today's agenda, we're going to be talking about the square. As said earlier, the lamest of all special quadrilaterals. Get it? You guys get it?
No.
They don't get it. All right, now, there's some very, very helpful things about a square. And the reason why we talk about it last is because of its special properties. Now, you guys all know what the definition of a square is. The definition of a square is, first of all, it's a quadrilateral. Also, to be more specific, it's a parallelogram. Parallelogram. Now, that is not its only definition. The two main aspects of it that make it a special parallelogram or special quadrilateral are this. First, it has 4 congruent sides. I'm going to annotate that now. Remember congruent sides? We mark with a dash. And all of these sides are going to be the same. So if this one is 4 1/2, all the other sides would be 4 1/2. Does this sound like another special quadrilateral that we've talked about? A rhombus, right? 4 congruent sides is the same as a rhombus. And we'll talk about those implications in just a little bit. In fact, that's really more one of the properties. Spoiler alert. The other property of a square is it has 4 congruent angles. And you guys know we mark those with arcs. But since we're talking about a square, what type of angles does a square have? They're all 90 degrees. In fact, I'm going to write that 4 congruent angles, all 90 degrees, or right angles. And we mark those with a little box. You guys know this will always be true. And this is very helpful for setting up equations, because if we know that they're referring to an angle, it has to be 90. Very, very easy equation to set up. And I think 4 congruent angles. What special quadrilateral has 4 congruent angles? Yes, the rectangle. This also has some really interesting implications. Rectangle. So this is just strictly the definition. We're talking just definition here. We're going to be talking about the properties shortly. All right? All right, so now that we've checked out the definitions, let's look at some of the properties of a special quadrilateral that is the square. To the next slide. To the next slide. Why are you coming out? Stop making me look like a fool in my own video. Where's the arrow button? Hold on. There it is.
Oh, it already played.
No, we're good. Oh, there we go. Come on, guys. We're going to get to this one, I swear. There we go. Sorry about that, watchers. Now, we have our properties. Now we're talking about properties. Now, the one nice thing about a square is a square does not have any properties that are exclusive to the square. There's no special square properties. In fact, all of the properties of a square come from its classification. The first set of properties come from the fact that a square is a parallelogram. Square is a parallelogram. So because a square is a parallelogram, it has all of the properties of a parallelogram. So let's go through, and we'll quickly go through those because we've gone over these multiple times at this point. Could someone tell me one property of a parallelogram? Go ahead. Congruent angles on opposite sides. Opposite sides are congruent. Well, we'll do opposite angles are congruent. Which would make sense in a square because, well, all of the angles are congruent. They're all 90. So if this one's 90, I also know that this one is 90. I mean, that's duh. Next property, we're going to be looking at what Lindsay said earlier is those sides. Opposite sides are congruent. Which again should not be surprising because all the sides are congruent in fact. Because, well, if we know this one is 4, that one have to be 4 as well. Opposite sides are going to be congruent. This is kind of nice about the square is most of these properties are relatively intuitive. Next one is the consecutive angles. The consecutive angles are supplementary. Which again shouldn't be surprising because, well, we know supplementary is blank plus blank equals 180. And we know that angles in a triangle, or sorry, angles in a square are all 90. So of course the two angles next to one another are going to be supplementary because 90 plus 90 equals 180. And then the last one. In fact, the last one's really the only one that really isn't that visible, or we don't know almost off the top of our head because of our because it's a square, is that the diagonals bisect each other. The diagonals bisect each other. Consecutive angles are supplementary. The diagonals bisect each other. And I'll draw that one in just so you guys can see, because I think this is one that we tend to make some silly mistakes on. So why not fix it now? In a square, if we have our two diagonals, notice there we go. The diagonals split each other in half. That's what I mean by bisect each other. They split each other in half. So, because a square is a parallelogram, it has these 1, 2, 3, 4 properties. If you have any more questions or you want to see better visuals on these 4 properties, check out my video on parallelograms, the properties of parallelograms. I'll see if I can get one of those cool little YouTube things that pop up and say, check out parallelograms. I haven't done that yet, so I'm going to try it. We good on property number 1. And I know it seems crazy that property number 1 has 4 pieces to it, but that's really what special quadrilaterals are all about, is if you're classified as one type of quadrilateral, you have all of its properties. All right, so let's check out the next set of properties. All right, so the next properties of a square, we'll call property number 2 if you want, is based upon the fact of what we said earlier. When we said a square is a rhombus. If a square is a rhombus, it has all of the properties of a rhombus. So a square is a rhombus. So it has all of the properties of a rhombus. Let's try this little thinner point, see if it works a little better. For a rhombus, remember it has 2 special properties. First property, the diagonals. Yeah, it's true for squares and rhombuses. The diagonals are perpendicular to one another. Perpendicular to one another. And I'll illustrate that in our diagram as well. If we draw in our 2 diagonals, I'm going to do them 2 different colors just to have some reference. Not get to the orange. There we go. Perpendicular meaning that where they intersect, thank you, are all 90 degrees. All 4 of these angles are 90 degrees. Remember another way of writing down perpendicular beyond writing out the word? is the upside down T. So if you see the upside down T, remember that also means perpendicular. That is one of the properties of the rhombus strictly because it is a square. The other property of a square, because it is a rhombus, is the diagonals. Sorry, let me get out of that. The diagonals sorry guys. The diagonals bisect each angle. And by angle, I mean the interior angles. So again, I'll illustrate what that means with our diagram to the left. If I know, for example, that this angle is 90 degrees, which all the angles are 90 degrees, this should not be surprising to anyone, right? Because it's a square. We talked about in the previous slide. Each one of these angles is going to be 45, 45, 45, 45, 45, 45, 45, 45. Let's make it look a little more like a 5. 46. Nope. 45. It bisects, it splits each one of these angles into two congruent pieces. All right, so now let's look at the last set of last set of properties for a square. Now, as previously stated, let's go back and look at this one. Not only is a square a parallelogram, not as only is a square a rhombus, it is also a rectangle. So it has all the properties of a rectangle as well. So, big property or big statement is a square is a rectangle. Square is a rectangle. Now, the one really nice thing about a rectangle is, in fact, it only had one special property that was different from the fact that it was a parallelogram. And that fact was the diagonals are congruent. The diagonals are congruent. So let me drop in our diagonals again, just so we have a reference. I'm going to drop them in pink. And the other one in blue, if I... Congruent. So we have our diagonals. I'm just going to call this square A, B, C, D. So we have some letter reference points again. So we have, if it's the diagonals are congruent, it is AC would be congruent to DB. These two diagonals are going to have the same length. And again, that's because it is a rectangle. Those two lengths are going to be the same. So, those are all of the properties of a square. And again, it doesn't have any properties exclusive to the fact that it is a square. It just absorbs the properties of the special parallelograms it is as well, based on its classification. It's a rectangle, it's a rhombus, it's a parallelogram. It has all of those properties. So make sure you check out my video on the application of these, and also make sure you check out my video on covering all quadrilaterals for a review. All right, thank you guys for watching. Please like and subscribe. Check out my next video.